right, guys, welcome to week 4 of remote learning. So we're going to try things a little different this round. I know most of you were not in love with Khan Academy, so I've decided to do something to try to make things a little bit better. What we're going to do is we are going to work on notes this way, and I want to teach the material this way. You guys can listen to me teach the material, and then the next assignment in your Google Classroom after these notes is a problem set. This one happens to only just be one problem, but it is a problem set each time that you will complete after watching these notes and upload your information. So one of your assignments also is going to be to upload your notes from this material. If you have the ability to print this document off, that would be fantastic, and take your notes on that. If not, you will need to do all of your notes on a sheet of paper, work the problems with me, and then upload it so that I know that you're taking the notes. So I see here on my screenshot that my notes look a little bit different than yours. Some things came and some things didn't as the notes came through. So just to be able to look at the document versus here on this screen. Also, you can pause it and you can take notes as you go. That's what I would suggest. So what we're looking for here is this entire next couple weeks is on sampling distributions, and sampling distributions are, if you consider the entire population, that information is called a parameter, and like the mean, average, the mean for the entire population is your parameter, and we're going to look at a simple statistic, and the statistic is based off of a sample, as you can see right here. We're also going to be looking for some sample variability. That's exactly what it means. Every sample that you pull, there's going to be a little variation in your data. If I had a group of 200 people and from those 200 people, I pulled like 3 samples of 10 and asked them the same question, there would be some variation in my sample. So what we're going to focus on here is, this is called p-hat. Right here is a P with a little hat on top. And p-hat is the proportion of what's going on in our sample, not in our entire population. So this right here is representing your mean. Then remember, that's mu. That's our mean of our entire population. That would be a parameter. And when I talk about it like this, mu of p-hat, that is going to be the mean of my sample, of just the sample set that I pull. So if I was saying, okay, I'm going to talk about, I want to know the entire population of the school. That's going to be my population, is our, every student in our school. And I pulled a sample of 20 people and found the average of them. Obviously, that's not the perfect mean because I haven't asked every single person. So that would be a statistic, not a parameter. We're also going to be talking about, so this was talking about our mean, and we are also going to be talking about our standard deviation. Remember, that's rho. Sometimes we call that standard deviation of X, and then the symbol also right here was standard deviation. So all the same standard deviation that we've talked about the entire time. To calculate our standard deviation, this guy right here is the formula that we're going to use. P, as it has for the last couple months, is representing the success rate of that sample, the percentage of, the positive percentage of what's going on with our data. And then Q is the complement of that, meaning whatever it takes to add up to 100%. And then our N value down here is our sample size. So if we were sampling 200 people, it would be 200 down there. If we were sampling, 90 people, it would, that would be our sample size. So those are the main things that we're going to talk about. We are covering chapter 17 in your textbook, which you do have home with you. I would suggest looking through those pieces and parts. I'm going to pull out some specific pieces as we walk through this chapter. We're focusing on one specific thing this time, and we're going to do 3 problems together. Now, I want you to take notes on all 3 problems, and then I want you to also do the sample problem set, and I want you to walk through all the pieces and parts. And I'm going to do our 3 problems on 3 different videos, just to keep them a little bit shorter. So I'm going to do problem 1 on this video, and then I'm going to do problem 2 and problem 3 on the other videos. So this says the Centers for Disease Control and Prevention report that 22% of 18-year-old women have a body mass index, a BMI, of 25 or more, which makes them associated with increased health risk. As a part of a routine check at a large college, the physical education department usually requires students to come in to be measured and weighed. This year, the department decided to try out a new self-report system. So it asked 200 randomly selected female students to report their heights and weights, from which their BMI could be calculated. Only 31 of those students had BMIs greater than 25. So they're self-reporting, not actually asking them their information. We're wondering at the end of this question, is this proportion of high BMI students unusually small? So let's figure out 31 of them, let's just figure that out in the beginning, out of 200 reported the fact, I'm gonna get my calculator, reported the fact that they had a BMI of greater than 25. So 31 out of 200, if you guys calculate that, that is 0.155, which is 15.5%. And we were told up here in the problem that we expect 22% of the 18-year-old women to have this. So we're wondering, wow, are we doing a really good job of keeping our BMIs down? Or maybe was there some faulty information in our reporting? Is this unusually small is the question. So we're going to keep this number right here. And remember, we're going to call this guy, he is the P of our sample. So we're going to call him P hat. So 15.5% is the actual percentage that we had reported here. We're going to get our other data before we switch to the next screen and draw our normal model. So our p-value here is the percent that we're expecting to get, percent of success, which is going to be given to us in our problem, which was 22%. We're going to call that 0.22. If P is 22%, then that means Q is the rest of the population, meaning that it's going to be 0.78, so 78%. Remember that these numbers always add up together to be 100%. So in our sample size here, this is information we're all going to need. Our sample size here was 200. We asked 200 students. So we have all the information that we need. These are the P and Q that's going to go in to help us calculate our standard deviation. This is the P hat that we actually have. And our average here, remember, our average number of students who we are expecting to report having a high BMI is 22%. So I'm going to come up here with my information. I'm going to say my mu. And according to your notes on the first page, your mu is always equal to your P, which is your 0.22, your 22%. I'm going to try to find my standard deviation of my statistic, of the population. What is this, the sample, I'm sorry, that I'm using? What is my standard deviation? According to the front page of your notes, remember the formula was P times Q all over N, which is your sample size. So in this case, it is 0.22 multiplied by 0.78 all over 200. Something's on my iPad. And when I calculate all that out, I'm going to type it in as we go. You guys should be doing the same thing. Pause the video if you need to. That is, I'm I'm going to round that to 0.03. So about 3%. So my standard deviation, my information deviates by about 3%. So the next thing we're going to do is we're going to draw our normal curve. So this data should be on a normal distribution. We have done normal curves multiple times throughout the year. So what we expected in the middle was 22% of our students to have a greater than 25 BMI. I'm going to go up with my 3 segments up, and I'm going to go by my 3, remember we called these Z-scores, down, or standard deviations. So if I would take my 22% that I was expecting and add in my 3%, this would be 0.25. This would be 0.28. And this would be 0.31. I'm going to subtract them to get 0.19, 0.16, and this is 0.13, which would be 13% of our population. Now remember, early on in the problem, we were told that 31 out of 200 people reported that they had a higher than 25% BMI, which was 0.155, which is somewhere between 15 and 16%, which we're going to find him right here. That's about my 15.5%. Now my question, if I come back to the question, was, is this proportion of high BMI students unusually small? So we're going to talk about small. We're going to talk about this area over here. What percentage would be smaller than that? What percent of the time would we have a smaller percentage reported than that is what we're trying to find. So the first thing we need to do is we need to find this Z-score of our data. So our Z-score, if you go way back in your knowledge, our Z-score was, we take our actual, so we're going to do p-hat, what our actual percentage is that we got. We're going to subtract our P, which is our mu, which is what we were expecting to get, and we're going to divide it by our standard deviation. We're basically figuring out how many of these chunks are we away, how many standard deviations are we away from the mean, how many of these 0.3s are we away from the mean. So in this case, I'm going to take my 0.155. I'm going to subtract out what I was supposed to get, 0.22. And I'm going to divide by the standard deviation that I calculated, which is 0.03. Now, pause if you need to. I'd like for you to go ahead and create this calculation. I got my answer to be negative 2.166 repeating. So I am 2.166 standard deviations below the mean. Now, we're working on a normal curve. So we're going to talk about a normal distribution. So we're going to find our normal CDF. So what I want you to do on your calculator is I want you to push second, and I want you to put the VARS button, which is over by your clear button. And when you push second and then VARS, you're going to see normal PDF and normal CDF. I want you to choose normal CDF. And you're going to be changing the first 2 numbers in your problem. Now remember, we're looking for what percent of our populations would fall below here. So we're going way to the left, and this guy right here is our upper boundary because he's on the right. And my Z-score there is negative 0.1266. So in this problem, we're going way to the left. Remember, just a really big, huge number that's negative. Negative 9999999. Let's put a bunch of 9s. And then I take my, my second number, my upper boundary is the Z-score that I just received, which is negative 2.166. Negative 2.166. I'm going to paste that guy in my screen, and what I got was this answer, 0.015-ish, meaning 1.5% of the time we would have information that would fall smaller than that percentage. So I guess my answer to this first question is yes. Is the proportion of high BMI students unusually small? My answer to this question would be yes. Only 1.5% of the time less, sorry, I was mixing two words together there. Less than, would I have 15.5% of the population? Would have a high BMI. So I guess my answer would be yes in this question.